In 2019, an AI locked onto a white van in Syria. A helicopter destroyed it. Later, they found out those were farmers coming home from work. And here's the thing, nobody wants to say out loud. No one was held responsible because no one made the decision.
Wait, so the system identified it, human operators authorized it, a helicopter fired on it, but nobody actually decided to kill those specific people. That is, I mean, that's the entire problem, isn't it? The sheer evaporation of accountability.
Welcome to Deep Into the Pages. Today, we are focusing on a book that fundamentally shifted how I look at modern warfare, accountability, and the intersection of human morality and machine speed.
Yeah, it's a heavy one.
It really is. The book is called Project Maven, a Marine Colonel, his team, and the Dawn of AI Warfare by Katrina Manson. We are taking you, yes, you listening to this right now, on a deep dive into the moral complexities of the Pentagon's algorithmic warfare.
Right, because we're exploring this diffusion of human responsibility. We're looking at a system where the lines between human intent and artificial output are not just blurred, they are intentionally architecturally erased.
Exactly. And we really need to sit with the gravity of that for a moment because
Yeah.
it is so easy to distance ourselves from this stuff.
Oh, absolutely. We aren't talking about science fiction here.
Right.
We aren't talking about some hypothetical Terminator future where autonomous robots suddenly wake up and decide to take over. I mean, we are talking about right now.
Today.
Yeah, we were talking about architectures of targeting and killing that have already been built, already been deployed, and are actively shaping conflicts around the globe as we speak.
And this exploration, it's going to require us to look closely at the choices made by a very small group of people, like a scrappy, almost subversive group within the Pentagon.
The ones who decided that the ancient bloody fog of war needed to be cleared by artificial intelligence.
Right, regardless of the structural cost. So I want to take us back to that white van. Let's
Yeah.
really paint the picture of what happened because it serves as the absolute anchoring narrative for everything we're going to talk about today.
Yeah, set the scene for us.
Okay, so it's October 2019. We are in northwest Syria. This is the night raid targeting Abu Bakr al-Baghdadi, the leader of ISIS. So establish the stakes in your mind. This is a massive, high-stakes operation.
The President of the United States is watching live.
Exactly. You have special operations forces on the ground in hostile territory, massive air power circling overhead, and an operations center in Erbil where analysts are staring at walls of screens trying to make sense of the absolute chaos unfolding in the dark.
And it is the ultimate manifestation of sensory overload. I mean, if you've never seen a live drone feed, you have to understand that it is not like watching a 4K movie on your television.
Not at all.
It is grainy, it is often thermal or infrared, meaning you are literally just looking at glowing blobs of heat against a dark background. The camera is miles in the air, vibrating, panning rapidly.
We have these human screeners, right?
Yeah.
Young men and women whose entire job is to stay glued to multiple feeds for hours on end looking for threats.
Yeah, and human biology simply isn't built for that. Eyes get fatigued, attention drifts, and the situation on the ground in the village of Barisha is chaotic.
So into this cauldron of human exhaustion, Project Maven's artificial intelligence is deployed. This is a computer vision model that was specifically funded and designed to do exactly what tired human eyes struggle to do, find geometric and thermal patterns in the noise.
And suddenly, amidst all that grainy footage, the AI pings.
It pops a telltale digital boundary box, a detection on the video feed. The system has spotted a dot moving south through the village, heading toward a T-junction, turning west toward the U.S. task force.
Which is the critical inflection point of the whole operation. The machine beat the humans.
Right.
It identified a moving vehicle in the dark before any biological operator staring at the same screen even realized it was there.
So the task force commander looks at the data the AI has flagged. He has to make a call. He assesses that the vehicle is displaying hostile intent simply by virtue of moving toward the ground force during a raid. He gets on the radio to the ground force commander and calls in a hit.
He says, take it out.
Take it out. And the gears of the military machine lock into place. 30 seconds later, an attack helicopter swoops in. Gunfire rains down. A strafing run blows out the walls of a building near the van. 5 minutes later, rockets are launched. The van is completely destroyed, left as a blackened, shot-up carcass beside a line of olive trees.
And let's look at the immediate reaction in the operations center in Erbil, because the task force commander had just used artificial intelligence to help find a target for the very first time in combat history.
Yeah.
It worked faster than anyone anticipated, but the reaction wasn't a solemn pause for the taking of human life. It wasn't a moment of reflection. Someone in the room remarked aloud, "Someone just made their company a lot of money."
I read that line in the book 3 times. Someone just made their company a lot of money. It is devastating because it reveals the absolute industrial commercial logic at play in the room where lethal force is applied.
It really does.
But here is where the technological triumph turns into a human nightmare. Later on, investigator journalists, including folks at NPR, dig into what actually happened on that dirt road in Syria.
What did they find?
That white van. It wasn't an ISIS technical. It didn't contain militants rushing to defend their leader. It was driven by a man named Barakat Ahmad Barakat. He was driving home with 2 of his friends. They were civilian farmers who had just finished their day's work at an olive press. They were just men going home, and they were obliterated.
And when the dust settles and the journalists publish their findings, you naturally ask the question that any civilized society asks, right? Like, who is to blame for the deaths of these 3 innocent farmers?
Right.
But the architecture of the system provides a chilling answer. The answer is nobody. No one was fired, no one was court-martialed, no one was held accountable.
How do we even process that?
Yeah.
3 innocent people are vaporized. Does the military-industrial complex just shrug its shoulders and write it off as an acceptable glitch?
It's not a shrug, though. That's the thing. It's a structural feature. It all comes down to the diffusion of responsibility. Look at the chain of events. Can you put the AI on trial?
Whoa.
No, it's a string of code matching a visual pattern of a vehicle based on a mathematical probability. It has no legal intent or malice. So can you blame the human operator staring at the screen?
Their literal job description is to relay what the system flags.
Exactly. What about the commander who ordered the helicopter to fire? If you pull them into a hearing, they will say, "I was acting on the best, fastest intelligence provided by a system that the Pentagon spent billions of taxpayer dollars to build, specifically because I was told it is superior to flawed human perception."
I see what you're saying. The human didn't overrule the machine because the machine's entire existence was predicated on the assumption that it was better than the human.
Right.
The system essentially functions as a machine that self-absolves everyone involved.
Yes. And if you build a system where the AI is treated as an oracle of absolute truth, and the human is reduced to a reactionary rubber stamp, you create a perfect, impenetrable loop of deniability.
Wow.
The commander is just acting on the data is just reflecting the algorithm's output, the algorithm is just doing math. So where does the moral weight of taking a human life actually sit? It evaporates into the cloud.
But I still can't get past that quote from the Ops Center. Someone just made their company a lot of money. If you were listening to this, think about what that means for the future of warfare. We are talking about American defense contractors, Silicon Valley venture capitalists, and military commanders celebrating a product demo that resulted in the vaporization of human beings.
It's grim.
It completely strips the solemnity, the moral gravity, out of the act of killing. It turns a battlefield into a pitch deck.
It absolutely commodifies the kill chain. It turns the battlefield into a proving ground for tech investments. And to truly grasp how we arrived at this terrifying point where a machine dictates life and death, and human operators celebrate the commercial viability of a lethal strike, we have to look under the hood.
Right, because this wasn't an accident.
No, this wasn't a glitch. The death of those farmers wasn't a bug in the code. It is the result of a meticulously engineered architecture designed to accelerate war and systematically absolve the human conscience.
Okay, then let's open that black box, because one of the most brilliant things Katrina Manson does in Project Maven is demystify what we mean when we say AI. The book makes a critical insight. Project Maven is not a glowing red eye.
Right. It's not HAL 9000.
Exactly. It's not a single AI sitting in a server rack. It's a vast, sprawling, interconnected infrastructure. It's a pipeline.
A pipeline is the perfect way to visualize it. I want you to imagine a piece of data, let's say, a blurry video of a white van, and follow its journey. The Maven system is essentially a 5-layer infrastructure. And what's fascinating and terrifying is that at every single layer, meaningful human judgment is progressively stripped away.
Okay, let's walk through it. Starting at the very foundation. Layer 1 is the data pipeline.
Because you can't have artificial intelligence without data, right?
Right. You need oceans of it.
Mm.
The U.S. military has drones flying 2047 across the Middle East, Africa, and Asia, generating petabytes of video footage.
Just endless amounts.
But raw, unclassified video is completely useless to an algorithm. An algorithm doesn't see a video, it just sees a grid of pixel values.
Mm.
To teach the AI what those pixels represent, the data has to be labeled.
Yeah.
So the military has human workers cut this endless footage into tiny, manageable clips, scrub it of classified signals, and send it out to commercial companies.
And this is where we get to companies like Scale AI, which became massively valuable, like billions of dollars valuable, doing exactly this kind of invisible grunt work. And then there's enabled intelligence, which the book points out actually hired autistic employees specifically because of their incredible focused abilities for pattern recognition.
Yeah, they needed humans to look at a screen and draw little digital boundary boxes around cars, people, buildings, trees, over and over and over again. They were constructing a billion-image training dataset by hand.
And on a micro-pixel level, those images might be clean, but the labeling choices inherently encode military assumptions. What constitutes a target? What constitutes suspicious movement? Human beings are deeply flawed labelers, carrying their own biases and fatigue.
Which leads to one of the most absurd, almost darkly comedic details in the entire book, the dirty data anomaly. Let me set this up because it blew my phone.
Oh, this story is wild.
Around 2017, Project Maven is deployed to Somalia. The goal is to use the AI to help hunt down al-Shabaab militants. But the system starts acting erratically. It's making bizarre, inexplicable mistakes. Specifically, the AI is looking at puffy white clouds in the Somali sky and aggressively labeling them as school buses.
School buses floating in the sky.
Yes, and the Maven engineers back in the States are panicking. They dig into the training data to figure out why the algorithms is hallucinating so badly, and they find the culprit. It turns out, early on, instead of paying expensive commercial data labelers, the military tried to save money by having actual enlisted service members do the labeling.
Oh, boy.
Picture it. Bored 19-year-old soldiers sitting at screens in windowless rooms for hours on end, tasked with drawing boxes around objects. And what did these bored human beings do? They drew penises. They drew obscene doodles all over the training images.
A soldier literally wrote the word F-U-C-K in boundary boxes across the images.
Exactly. The most powerful military in human history, armed with the most advanced technology ever conceived, was building its state-of-the-art AI weapon system on data that bored teenagers had vandalized for a laugh.
It's unbelievable.
But while it sounds comical, the technical reality is horrifying. How does a neural network process a drawn penis? It doesn't know what a penis is. It just mathematically registers the contrast, the edges, the gradients of those shapes, and associates those pixel patterns with whatever label it was supposed to be learning. The AI learned those incorrect, vandalized patterns.
And that proves a fundamental law of AI that listeners need to remember. The system scales human flaws just as efficiently as it scales human strengths. A bored soldier making a joke literally poisoned the entire intelligence pipeline.
Wow.
Which brings us naturally to layer 2, the algorithm. This is where that data, dirty or clean, gets put to use. These are the actual computer vision models. The military contracts tech giants, Microsoft, Amazon Web Services, Clarify to take that massive data set and train models on the military's secure cloud. They iterate these models every 45 to 90 days. The goal is to teach the software to recognize tanks, Russian transport, Erector launchers, artillery pieces, and civilian vehicles.
But let me make sure I'm wrapping my head around the mechanics here.
Yeah.
Because I think people assume the AI becomes smart. The algorithm doesn't know anything, does it? It doesn't understand the context of what it's looking at.
Not even a little bit. To an algorithm, a white van is just a collection of pixels that probabilistically matches a pattern it was trained on. It has no concept of a van in the real world.
Right.
It doesn't know if the van is full of explosives destined for a checkpoint or full of civilian olive farmers going home to their families. It cannot distinguish between matching a mathematical pattern and understanding the context of a war zone. And yet, the military architecture treats its mathematical output as actionable intelligence.
So once you have this algorithm, you have to actually use it in a war zone, which is layer 3 edge computing. They call it the MAPB box. This is where the pristine, air-conditioned reality of Silicon Valley tech violently collides with the physical reality of war.
Yeah, physical reality always wins.
To process all this massive AI video data in the field, They pack these gigantic NVIDIA graphics processing units, GPUs, the same things that run high-end gaming PCs, and mine crypto into physical server boxes and ship them to forward operating bases in places like Afghanistan.
And the physical environment of a war zone absolutely rejected them. We are talking about $2 million machines that literally melted.
Melted.
They caught fire because they couldn't handle the ambient heat, the fine desert dust, and the unstable power grids of a forward operating base. The cooling systems completely failed.
I love the story of Colin Carroll in the book. He's one of the key military guys driving the Maven team. He completely ignores the design advice of his primary contractor, a woman named Katya Volkovska. He insists, in typical military fashion, on packing 8 massive heat-generating GPUs into a single box to maximize computing power.
Of course he does.
And then a few weeks later, he has to call her while she's on holiday to quietly admit, "You were right, they're on fire."
It's the perfect metaphor for the hubris of the entire project. But they don't stop. They iterate. They realize that putting big servers at ground bases is too slow, too fragile, and requires beaming heavy video files down from the sky.
Right.
So the evolution of Layer 3 is to push the AI directly onto the drone sensors themselves. Instead of beaming a raw video back to a base for an algorithm to process, the drone's own camera pod has the AI baked into the hardware. It identifies targets in flight, in real time.
Which solves the server melting problem, but creates a massive ethical one, because it drastically increases the speed of detection, but it completely severs the human oversight.
Exactly.
Previously, analysts reviewed the footage back at the base, debating what they were seeing. Now the drone makes the call in the sky. Speed increases, human oversight decreases.
Exactly. And once that data is generated by the drone, it has to go somewhere. That is Layer 4, the fusion interface. This is the realm of the Maven smart system, heavily dominated by Palantir. This is where things get genuinely dystopian.
Dystopian is the word.
Because the military isn't just looking at drone video anymore. This system takes satellite imagery, the AI visual recognition from the drones, and intercepts from cell phone signals what they call SIGINT, or signals intelligence.
Let's pause and explain SIGINT for the listener.
Yeah.
How does that factor into an AI targeting system?
Sure, so every time a cell phone searches for a network, it shakes hands with a local cell tower. The military intercepts those signals. If they have the phone number of a suspected terrorist, they can track the geolocation of that phone based on those tower pings.
Okay, that makes sense.
Now imagine the Palantir Fusion interface. It's the ultimate single pane of glass map that military commanders have dreamed of for decades. If the AI vision spots a vehicle moving down a road and a cell phone signal associated with a suspected militant pings at that exact same geographic coordinate, the Maven smart system instantly fuses those two disparate pieces of data.
It connects the dots for them.
Right. It pops a glowing blue box on the commander's screen that essentially says, high-value target here, 95% probability.
But what's really happening psychologically to the human operator staring at that screen?
That's the most insidious part. The system is subtly telling the operator what is important. The machine is doing the reasoning. Because the machine has fused all this incredibly complex data visuals, signals, geospatial math, the human operator stops asking questions.
Because they can't possibly double-check all that math in real time.
Exactly. The software's black box is too complex for a human to interrogate in real time, especially under the stress of combat. So the operator simply defers to the blue box. The critical thinking is completely outsourced to Palantir's user interface.
And that deference leads to the final fatal step in the pipeline. Layer 5, the target workbench. The final click. The commander looks at the blue box on the screen, accepts the machine's identification of the target, and literally clicks a mouse.
Just a click.
The system instantly calculates the coordinates, cross-references it with friendly troop positions, and matches the target with the optimal available weapon system. It might digitally tap an F-22 stealth fighter that's 82 miles away, or a HIMARS rocket artillery system on the ground, transmitting the firing solution instantly via a secure tactical data network called Link 16.
This is what the military calls automating the kill chain. And the human being's role at this final stage is terrifyingly diminished. Think about Joey Temple, a targeting expert with the 18th Airborne Corps who is profiled in the book. He talked about how, with the AI's assistance, his job became a rapid-fire sequence of simply concurring with the machine.
He called it accept, Except that was his exact phrase. He could sit at his desk and sign off on 80 targets an hour.
If you're listening to this on your phone right now, think about how often you mindlessly click accept on a terms of service pop-up or a cookie consent form.
Oh, man, constantly.
Now imagine doing that, but the pop-up is authorizing a lethal artillery strike. When you are signing off on more than one target every single minute, you are not making a reasoned decision. You are providing legal authorization, and authorization is not decision-making.
Right. The system has already made the determination that this is a legitimate military target.
The human is just the biological requirement pulling the trigger to satisfy international law.
And this right here is the core of the responsibility gap. At no point in that entire 5-layer pipeline, from the bored teenager drawing boxes to the melting GPU to the Palantir map to Joey Temple clicking, except does any single individual exercise independent, meaningful judgment about whether taking that specific human life is morally and legally justified.
It's structural diffusion. You know, looking at this architecture, it reminds me of an ancient historical practice. Think of the Roman snake oracle or the sacred chickens.
The sacred chickens.
Yeah. In ancient Rome, before a general went into battle, they would consult the sacred chickens. A priest would scatter grain before them. If the chickens ate eagerly, it meant the gods favored the attack. If they refused to eat, the omen was bad and they shouldn't fight.
I'm tracking with you, but how does this connect to an AI targeting system?
Because the Roman general always had the power to override the chickens. He was the commander. But they rarely, if ever, did. Why? Because the ritual existed specifically to distribute responsibility.
Ah, I see.
If the battle was a catastrophic loss or the slaughter was horrific, the general didn't have to own the moral weight of the failure. He could stand before the Senate and say, the chickens told us to attack. The gods ordained it. I was just following the divinations.
Wow.
Project Maven is the 21st century sacred chicken. When a modern commander says the AI flagged the target, it's a structural way of ensuring no human being ever has to stand up and say, I alone decided to kill those people in that van. The algorithm acts as a moral buffer.
That is a brilliant analogy, and it's terrifyingly accurate. It's exactly the same logic driving the adoption of self-driving cars in the commercial sector right now. You have tech executives standing on stages saying, look, AI doesn't drink alcohol, AI doesn't text while driving, AI doesn't fall asleep at the wheel, therefore it is mathematically safer than human drivers, and we have a moral imperative to deploy it immediately to save lives.
Right.
But then they deploy these autonomous vehicles onto city streets before the edge cases are fully solved, driven entirely by the commercial race to beat their competitors to market.
And what happens when it fails?
Exactly. When a self-driving car makes an error, when it misidentifies a pedestrian walking a bicycle as empty space and someone is killed who is legally and morally responsible, it's the algorithm. You can't put code in jail. Is it the human safety driver who is explicitly told by the company to trust the system's capabilities? Is it the corporation that rushed the beta product to market?
It's a
Responsibility is diffused across an entire supply chain of accountability, where every single link can legally point the finger at another link. The military version of this is identical. The only difference is that the pedestrians are being killed with Hellfire missiles, and the corporation is Palantir, whose stock price objectively rises with every new global conflict.
It is an architecture of absolution. But as horrific as this sounds, it is very easy for us to sit here in a comfortable studio and condemn this system. If we want to be intellectually honest, to truly understand why the U.S. military felt compelled to build Project Maven, we have to look at the human trauma that demanded its creation in the first place.
Yeah, that's fair.
We have to look at the people who believed, down to their bones, that AI was the only ethical way forward.
I'm glad you brought that up, because this leads us into what I think is the most uncomfortable, thorny argument in the entire book. Let's talk about Brian Ward.
Brian Ward is a fascinating, tragic figure. He was an Air Force intelligence analyst. Let's set the scene. It's 2011. He's stationed in Indiana, safe in the United States, but his mind is 7,000 miles away.
Right.
He's working a drone feed that is flying over the Sangin Valley in Afghanistan. It's the middle of the night. U.S. Marines on the ground take heavy fire from insurgents. Ward is watching the grainy drone feed, trying to provide situational awareness to the commanders. And amidst the chaos, a horrific, cascading mistake is made by the human operators, the radio communicators, and the commanders. A U.S. drone is cleared to fire a missile. The missile hits. But it doesn't kill insurgents. It kills 2 U.S. Marines and a Navy corpsman. Friendly fire.
Ward is sitting in Indiana, and he watches his own countrymen die on a screen because of a human communication breakdown. He watches them bleed out in infrared, and the psychological toll that takes on him is immense.
Unimaginable.
The book describes him feeling absolute disgust for normal society after that. He would go to the grocery store and he couldn't stomach hearing regular people complaining about their mundane lives, their traffic jams, while he was making life-or-death call-outs on 48-hour shifts without sleep.
But here is the crucial pivot in Ward's life. He doesn't quit. He doesn't walk away from the military in protest. Instead, he doubles down on artificial intelligence.
Right.
He looks at that friendly fire tragedy and concludes that human beings suffering from fatigue, adrenaline, stress, and cognitive overload make fatal, horrific errors. To Ward, machines must replace tired humans because a machine doesn't get sleepy. A machine doesn't panic when it hears gunfire on the radio.
And you really have to contrast Ward's reaction with the people building the AI over in Silicon Valley, people like Laura Nolan at Google or Joe Redman, who created the YOLO algorithm.
Let's briefly explain YOLO for the listener because it's vital. YOLO stands for You Only Look Once. Before Joe Redman invented this, computer vision models were slow. They had to scan an image multiple times, one pass to figure out where objects might be, and another pass to figure out what those objects were. It was too slow for real-time video.
Way too slow.
Redman wrote an algorithm that passes the image through the neural network exactly once. It instantly divides the image into a grid and predicts bounding boxes and probabilities simultaneously. It made AI vision real-time. It's the reason a drone can track a moving white van.
Right, so Google partners with the Pentagon for Project Maven using these open source concepts. And when Google employees found out their company was building AI for military targeting, there was a massive internal revolt. Remember Google's old motto, "Don't be evil."
Yeah, that didn't last.
Laura Nolan, a brilliant software engineer, literally developed nightmares and acid reflux over it. She quit the field entirely because she couldn't stomach the idea of her code being used to drop bombs. Joe Redman saw his open-source YOLO code being used for military applications, and he just walked away from computer vision research completely.
So we have a profound, genuine moral debate here. You have the Silicon Valley engineers walking away for the sake of moral purity, and you have the military analyst, Brian Ward, demanding more AI because of his own moral trauma.
And I have to say, reading this, I actually find Brian Ward's logic deeply compelling. And that makes me incredibly uncomfortable. But he's not wrong. Human beings working 24-hour shifts, staring at screens, make terrible, catastrophic mistakes. Look at the history of modern warfare before AI.
I mean, sure, but
The U.S. military bombed a Doctors Without Borders hospital in Kunduz, Afghanistan. They bombed the Chinese embassy in Belgrade because an intelligence analyst literally didn't update a paper map. We are talking about hundreds of thousands of civilian deaths in Iraq and Afghanistan caused by flawed human intelligence, cognitive bias, and sheer biological exhaustion. I'm sorry, but you cannot blame Brian Ward for wanting a machine to take the reins when human biology is causing so much undeniable tragedy.
I hear you, and I understand the emotional weight of Ward's trauma, but here's where I have to push back fiercely. Ward's logic is fundamentally flawed. It assumes that because the machine doesn't get tired, the overall error rate will go down, but he completely ignores the kind of errors being made.
How so?
Let's look at the difference. A tired human analyst who accidentally bombs a wedding because they misread a map or fell asleep at the console, that is a sloppy, tragic human mistake. But an AI might perfectly classify a school as a valid military target simply because its training data taught it that buildings of a certain architectural shape in a certain geographic region are targets. Both scenarios result in dead civilians, but one is a mistake, the other is a mathematical feature. The AI isn't wrong in its own logic, it is doing exactly what it was perfectly built to do.
Wait, I disagree. A structural error in code can be patched. If the AI misidentifies a school, you can update the algorithm. You can feed it better data. You can tweak the F1 scores.
Let's explain F1 scores for the listener real quick.
All right, so F1 score is basically how you measure the AI's accuracy by balancing precision and recall. Precision means out of everything the AI flagged as a target, how many were actually targets. Recall means out of all the actual targets out there, how many did the AI successfully find?
Right, it's a trade-off.
If you crank up recall so you don't miss any terrorists, you end up flagging a lot of white vans by mistake. You can tweak that dial in the code. But human fatigue, cognitive bias, adrenaline, those are permanent, unpatchable biological flaws. You cannot download a software update for the human nervous system.
That's true,
But frankly, I challenge the morality of the Silicon Valley objectors here. Laura Nolan and the Google engineers had the luxury of moral purity sitting in their beautiful free food cafeterias in Mountain View. Brian Ward was in the dirt, metaphorically and literally watching young men bleed to death on a monitor. He didn't have the luxury of quitting. He is trying to solve a very real, very bloody problem with the only tools he has available.
But those structural errors you say can be patched are vastly more dangerous precisely because they are so much harder to see as errors at all. They get hidden behind the math. Go back to the white van in Syria.
Okay.
That van wasn't misidentified because the AI was tired or distracted. It was misidentified because the logic encoded into the system by its human creators taught it white van plus moving toward a task force in a conflict zone equals target. It is an industrialized, systematic error. It operates at scale,
I see.
and it's built by defense contractors and commanders who consistently refuse to admit the system is broken, because admitting it's broken means stopping the deployment and losing the contract. A human mistake is singular and localized. An algorithmic mistake is systemic and replicates at the speed of light across the entire globe.
Okay, that is a heavy point, and I concede it. Because you're right, looking at the history of Maven, Brian Ward never stopped to ask the bigger existential question. He was so traumatized by the how of the killing that he never questioned the why. He never stopped to ask, maybe the problem isn't the AI's accuracy. Maybe the problem is the fact that we are running a global military apparatus where a van full of farmers gets blown up and nobody gets fired. He didn't want to stop the war. He just wanted better, more efficient tools for a morally broken system.
Exactly. He wanted to fix the symptoms of the war machine without questioning the machine itself. And this relentless pursuit of better tools, regardless of the moral cost or the structural failures, wasn't just happening at the analyst level with guys like Ward. It was being driven from the very top echelons of power.
The people calling the shots.
The architecture of absolution we talked about was the result of a terrifying marriage between military bureaucracy and Silicon Valley hubris.
Which brings us perfectly to the architects of this system. If we want to understand how algorithmic errors get pushed to the battlefield, we have to talk about the culture clash between the military and big tech. We have to talk about the cult of speed and corporate war. The two figures that really embody this in the book are Drew Kukor and Alex Karp.
Let's start with Drew Kukor. He was the military driving force behind Project Maven. He's a Marine colonel, and Katrina Manson describes him almost like a Don Quixote figure tilting at windmills.
How so?
Since the 1990s, he had been railing against the military's slow analog intelligence gathering. He saw Marines dying in the Gulf War from friendly fire simply because they didn't know where anyone was on the map. He famously carried a completely useless, heavy computer server into a forward operating base in Afghanistan in 2001 and ended up just using it as a room heater because the military software was so terribly designed.
He used a server as a heater.
Yeah, he was quoted saying, "Microsoft is where data goes to die."
Wow.
So, fast forward to the 2010s, Kukor essentially operates like an aggressive tech CEO trapped within the Pentagon. He bullies the bureaucracy. In 2011, he literally sneaks unapproved Palantir servers into Afghanistan against the Army's direct, explicit orders just to force the military to start using modern data fusion.
He cultivated this complete insurgency mentality. The Mavenites, as his team called themselves, operated out of a windowless room in the Pentagon. They ditched their uniforms and wore Lululemon and Allbirds. They screamed at each other over whiteboards.
Very Silicon Valley.
Kukor pushed minimally tested beta AI systems into hot wars because he adopted the Silicon Valley ethos, move fast and break things. He believed the only way to improve the tech was to field it, break it, and learn from the data. But he was applying move fast and break things to literal lethal warfare.
And his ultimate enabler in this crusade is Alex Karp, the billionaire CEO of Palantir. If Kukor is the military bulldog, Karp is the Silicon Valley philosopher king of the military-industrial complex.
He's an interesting character.
Karp is an eccentric guy who refuses to sit down in meetings. His entire executive team stands up around him just to match his macho, kinetic, pacing energy.
Karp's rhetoric is legitimately terrifying if you think about the power he wields. He speaks about AI not just as a software tool, but as a weapon of mass disruption. He compares large language models to uranium. He has this wildly combative, almost unhinged persona. At one point in the book, he fantasizes out loud to a reporter about starting a drone company for the sole purpose of spraying fentanyl-laced urine on Wall Street short sellers who bet against Palantir's stock.
Which is an incredibly revealing thing for the CEO of the military's most powerful AI targeting partner to say out loud. It shows a complete detachment from the solemnity of lethal force. To him, drones and targeting are just a game of dominance.
And that aggressive tech mindset infects the military commands who are actually using the technology. Listen to this quote from Colonel Joe O'Callaghan, who was pushing the Maven system at the 18th Airborne Corps. He said, "Maven is a movement. We've drunk the Kool-Aid."
We've drank the Kool-Aid. Let that sink in.
Think about the grim, dark irony of that statement. Using a phrase that originates from the Jonestown Massacre, where over 900 people died from blindly following a leader and drinking poison flavor aid, using that specific phrase to enthusiastically describe the military's adoption of an automated targeting system. It shows a total, uncritical surrender to the momentum of the technology.
And that momentum is accelerating exponentially. The danger we are talking about isn't static, it's scaling. The book details how, initially, relying on human analysts, the U.S. military might hit under 100 targets a day in a major conflict. With Maven's computer vision deployed, that capacity scaled to 1,000 targets a day.
A tenfold increase.
But then, they started integrating large language models, LLMs, the exact same underlying architecture behind ChatGPT, into the Maven platform.
Wait, how does an LLM help with targeting? ChatGPT writes emails, it doesn't drop bombs.
Right, but think about what an LLM does best. It processes massive amounts of text instantly. In a war zone, you have thousands of intercepted text messages, radio transcripts, logistics reports, and intelligence briefings coming in every hour.
Oh, I see.
An LLM can read all of it, translate it, summarize it, and cross-reference it with the visual drone data in milliseconds. When they integrated LLMs, the targeting capacity exploded to 5,000 targets a day.
You have to ask yourself to consider the math here. If you are listening, just stop and do the math in your head. If an AI system is generating 5,000 targets a day, how much time does a human being actually have to review the context of a strike?
In a 24-hour period, assuming nonstop operations, 5,000 targets means a new target is generated every 17 seconds.
17 seconds. You cannot thoroughly review intelligence, assess the potential for civilian collateral damage, understand the complex pattern of life of the target, and weigh the moral proportionality of a missile strike in 17 seconds.
It's impossible.
It is physically, legally, and cognitively impossible. The human is entirely reliant on the machine's summary. The speed of killing has fundamentally, mathematically outpaced the speed of human moral reflection.
And we saw this play out in real time when the system was used to support Ukraine against Russia. The U.S. military was using Maven's advanced AI to identify Russian targets and passing those coordinates to the Ukrainians on a silver platter to be destroyed by HIMARS rockets. They are proving that you can automate the kill chain at a massive industrialized scale. But as one official quoted in the book put it, it's like being a puppet master, but eventually the puppet gets its own brain.
When the speed of war eclipses human thought, we are forced to look inward. We have to examine our own relationship with the tools we use every day, even outside the military context. Because the logic of Project Maven is the logic of modern automation everywhere.
Which brings us to what we personally took away from this deep dive into the source material. This book really forces a mirror onto the reader.
It really does. For me, my biggest takeaway is about the battle between productivity and accountability. I've spent years thinking about how technology changes the way we work. I look at automation, AI co-pilots, machine learning in the corporate world, and I always framed it in my mind as a productivity story.
Right, how to do things faster.
How do we do things faster? How do we remove friction? How do we increase output? But after reading Project Maven, I realized I've been asking the fundamentally wrong question for years. I kept asking, does the AI get it right? Is it accurate? When I should have been asking, who suffers when it gets it wrong?
That is such a critical shift in perspective.
And the answer in the Maven architecture is nobody suffers except the victims. The responsibility completely evaporates. The commander blames the AI's blue box. The AI is just probabilistic code. The tech contractor blames the dirty data. The data labeler is a bored teenager who doesn't know what they are clicking.
It's a perfect circle of blame.
That realization has been sitting with me in a way I cannot shake. I've started looking at every single automated system I interact with completely differently. Whether it's an algorithm approving a mortgage loan, filtering resumes for a job, or driving a car down my street, I don't ask, is it accurate anymore? I ask, who is accountable when it fails? Because if the answer is no one, the system is inherently dangerous.
That resonates deeply. For me, the thing that stuck with me most is the story of Joe Redman, the YOLO creator. It's about the asymmetry of impact. Redman is a guy who created one of the foundational open source algorithms for real-time object detection. It was an incredible academic achievement. But when he saw his code being used for military targeting and mass surveillance, he had a profound crisis of conscience. He stopped. He quit the entire field of computer vision. He walked away from his life's work.
And what happened after he took that moral stand?
Nothing. Absolutely nothing changed. The military kept using his code. Other developers eagerly stepped in to update it and improve it. His individual moral stand was profound for him personally, but it didn't slow the war machine down for a single second. I think about that asymmetry of impact constantly now.
Yep.
An engineer's conscience can stop them personally, but it cannot stop the system. I've already started thinking differently about the tools I use and the things I build in my own life. I don't just ask, can I do this, or is this ethical for me to do? I ask, if I stop, does the system still run without me? And if the answer is yes, then maybe the problem isn't the tool itself. The problem is the system that demands the tool.
That's a heavy realization. It really makes you question the power of individual agency in an increasingly algorithmic world.
It does, which brings us back to where we started today. That white van in Syria is still driving through this episode in my mind, and the question we opened with, who decides who dies, turns out to be the wrong question entirely.
What's the right question?
The real question is, in a system where nobody decides, everyone decides. And that is so much worse. Because when everyone decides a little bit, the labeler, the coder, the commander, no one is holding the bag. The farmers in that van didn't die because an AI made a math error. They died because the entire architecture of the system was perfectly designed to make killing incredibly easy and accountability entirely impossible.
So what do we do? How do we exist in a world where this is the new reality of conflict?
The first step is to stop pretending this is a conversation about technology. It's not about graphics, processing units, or F1 scores, or neural networks. It is about who we as a society are willing to let die without consequence. And that question, who gets to live and who dies, that is not a machine question. That is a deeply fundamentally human question, and we keep outsourcing it. We keep building sacred chickens to make the hard choices for us.
Before we go, I want to leave you with one final thought to mull over. We've spent this entire time talking about the military using AI to target adversaries in foreign war zones. But what happens when domestic law enforcement starts using these exact same algorithms, trained on this exact same flawed data, on the streets of your own city? When a police drone misidentifies a vehicle in your neighborhood, who takes the blame then? The patrol officer, the tech company, the algorithm. It's something you need to think about because the architecture is already here. That's it for this episode of Deep Into the Pages. If you want to wrestle with the responsibility gap yourself, and I hope you do, Katrina Manson's Project Maven is waiting for you. We'll be back soon with another book that won't leave you alone.